Welcome to our live webinar on how to upgrade field-level connectivity with state-of-the-art applications. My name is Renee Bassett, Chief Editor of Automation.com, and I will be your moderator for today's presentation. Today's presentation is being co-hosted by Automation.com and Softing Industrial. Thank you for joining us. Now, about today's presentation, which focuses on how to integrate field bus networks into modern DCS systems. Because many process plants contain the control systems of many different manufacturers and many different generations of technology, it can be difficult to exchange production and plant data across systems. However, process automation gateways can connect sensors, devices, control systems in production plants, both horizontally and vertically, integrating field bus networks into modern-day decentralized control systems, thus enabling the digitalization of the process plants. Today's presenters, Thomas Schwarzenbach and Skelly Shayla, are from Softing Industrial, and they're here to discuss the special challenges of digitalization in the process industry. They will present use cases for process automation gateways in general and answer questions about using gateways, including Softing's Smart Gates product. So, without further delay, let's hear from Skelly and Thomas. Welcome, gentlemen.
Yeah, thank you very much, Renee, for this beautiful introduction. My name is Thomas Schwarzenbach. I'm giving the introduction to our presentation, Upgrade Field-Level Connectivity with State-of-the-Art Applications. So, quickly, the agenda. We are going to talk about the introduction, then what's digitalization in general and what is needed for, and thus there are some challenges coming with the need of digitalization, especially in the process industry. And we're going to talk about the solution to those challenges. Obviously, we provide one from Softing. That's what we're here talking about that. So starting with the introduction, or going further on with the introduction, quick note about Softing in general. So we're a fairly big company consisting out of 400 employees in total. We got 3 different units. One is automotive, one is IT networks, and one is our unit, Industrial. In general, Softing is concerned with communication networks in different areas. So automotive, there's multiple communication networks. IT networks is concerned with cabling, especially in server architecture platforms, whatever. And we are concerned with industrial automation, industrial networks, industrial Ethernet, field bus, and whatnot. And that's what we're focusing in Softing Industrial. And thus we are product managers. So I'm Thomas Schwarzenbach here on the left-hand side, automation engineer. And with me is my colleague Skelly.
Hi, everybody, and also a warm welcome to this webinar, and thank you for joining this webinar from my side. Grüß Gott from Germany, I would say, and also thank you, Renee, for your great introduction. My name is Skelly Shayla. I'm product manager at Softing since 2018. I'm a mechatronics engineer, and I also have a degree in innovations and technology management. This from my side. I will start this here with the steps of knowledge from AJ North. He has a pretty nice module about the steps in knowledge we have in companies and in general. So everything starts from symbols, which can be any kind of values. These symbols get somehow with magic into data, turn these data into information. Out of information, we can have knowledge. With knowledge, we can react, and by reacting, we can optimize. And if we optimize, we generally have a benefit out of it. The first part is the part of information management, and the second part is the knowledge management level. So it's separated. So what is information and what is knowledge? Information is really the gathering of data and bringing them together to have a big picture out of it. And knowledge is really the intellectual assets of your company or of you in person if you see this for your on your personal view. So the knowledge and the ability to react and the ability to react in the right way is really the intellectual asset of everything. So what is our main target in this thing here is that we want to speed up this process from where I get simple symbols or where I get new information and reacting extremely fast and bringing the optimization and bringing the benefit as fast as I can to my plant, into my company, into my doing. Having this by time, so we are trying to squeeze it and make it happen in less time and make the benefit. And this here, the time we save or the time we win is the advantage we have over any competitors. And how can we do this? So that's the big question. How can we speed up this process? The process mainly can be, for sure, be accelerated by better information management, by better knowledge management, by know more. But this all is only possible if we have digitalization and if we use our digital systems, which helps us increase the processing of these information at all. Yeah, which brings us to our second chapter. What is digitalization and why do we need it? So digitalization at all is really just transforming analog values into digital formats in order to process them with the help of IT systems. So I can save them, I can copy them, I can duplicate them, and for sure I can analyze them. For why do I need this? So the data. So why do I need digitalization? Because I can save, copy, and duplicate and analyze data without digitalization. Why? Data processing is way much faster if we use the help of computers. I can save or make any number of copies as I want and spread them around the world in real time. There is less space required for the archives, and there are less errors because computers don't make errors, and there is no misrepresentation of any data or any information because it's all about zeros and ones as soon as we go into the computer. So there is no misrepresentation. So what can I gain from them, or what do I get from digitalization, or from the new information I get, and from the faster processing of all my data? I can gain efficiency. I can optimize all my asset performance. I can even identify any cost reduction opportunities. I can increase productivity at all. I can develop new opportunities or new business models with the information I did get from my system. Moving on and bringing this into automation, we have here our steps of knowledge, and here our pyramid of the automation with its 5 levels. We somehow can try to combine them, and if we go into automation, we really see that the information management part is our OT level, and the knowledge management is our IT management. So the upper, like the supervision level, the planning level, the management level. Up here, I make all my data analytics. I have my cloud-based solutions that really mine all these information and make the best out of them. If we go into process industry and come back to our steps, symbols are in process of industry process values. They turn into data and into information via our field devices that measure those process values. Those information go into control systems, which have the information about those devices and make out of the process value really information. Going high end levels, the knowledge level is our supervisory level, the reacting is our planning, where we plan, and then the upper level is the management. So the biggest challenge, as we see here in this picture, there's a really big gap between those systems, between the information management and the knowledge management. So our main goal is really to try to put our hands onto this gap and try to squeeze it together and to make it happen so it can work in between. Also, if we go back into the information system, we see here also there are gaps between the systems. There are gaps between the field level and the control level. There are gaps inside of the field level and the control level. Those gaps are really information gaps where I can't communicate between them. And also in the higher levels, I have gaps between all my levels, and I have difficulties in communicating between those levels. So for sure, the market has seen this problem before and has developed a lot of standards. Those standards help us to tackle those gaps and try to squeeze them together. So this is the standards, and if we say here, okay, we have a lot of standards, and to be honest, standards, thank you for nothing. We have so many to choose from. There's a variety of standards, and as a normal user, we're overwhelmed with all these standards and don't know which standards or which protocol is the best for me, which one fits me the best, which one do I need for my application. So the question is really hard, which leads us to the third chapter, the challenges for digitalization and in the process industry. This one here is really the hardest challenge we have faced, to choose the right protocol, to choose the right standards to communicate through all these levels in the automation. For sure, we have also other challenges that we are facing. If we look into the process industry, we see that almost 80% still use only 4 to 20 milliamperes in their applications. Even if they have hard protocol installed in their devices or others, they are only use those analog technologies because it works. So they say to themselves, why do I need all this data? My application is working, my plant is just doing fine. If I have a problem, there is somebody from the service team he will clear it, and I don't need any more information. Just a second, we have a poll questions on here. So the question is, which protocol do you use in your system the most? So do you face any of those protocols that are being listed in here? Okay, I have the solution of it. So I see from the attendees, about 20% use hard, 12% of you use Foundation Field Bus, 8 use Profibus PA, only 12 use Profinet, the remaining 48% typed others. Let's proceed. Okay, the other challenges. So there's still a lot of people who only use 4 to 20 milliampere. One of the other challenges is really a cybersecurity problem. A lot of people and a lot of plant operators are afraid of using those new technology and open up their plant to any platforms, to cloud platforms, because they're afraid of hackers. And we have seen a lot of hackers attacks and yeah, all around the world. So this is also a big challenge that we have to face and overcome. The other one for sure in the process industry is that we have high investment costs and long plant life cycles. Those oil and gas plants or wastewater plants, they're extremely expensive, and we have here extremely high investment costs. So we don't do any change of the plant or update the plant on a daily basis like it's in the factory automation where we have an update of the plant every 5 or 7 years. This can't be done in the process industry. But the hardest challenge from all of them is that I have too many standards to choose from. We don't know which one fits my application best. We don't know which one is supported by my usual supplier. So it can be that I want to have this and that for, let's say, for Foundation Field Bus, and my supplier doesn't support Foundation Field Bus. He only supports Profibus PA. And that's also a big challenge that we have to handle and maybe plan in a different way. So we're here at Softing say, okay, solutions from process automation, let's just use gateways. And if we go back to our automation pyramid and let's say make this example, we have here Modbus control system and Modbus devices, and we want to update our plant, or there is an application that will be best if we use their foundation field bus. But those systems are not consistent. So I can't combine foundation field bus with Modbus, and it's extremely complicated to combine those worlds. And we here at Softing, we didn't like it that is so complicated. So we are saying, okay, we don't want you guys to have, or also we have to get those foundation pupils data into every level, and this makes it even really harder. And so we at Softing say, hey, don't make any compromise. Don't let you being said that that's not possible combining those systems. Make the best out of your application, your plant. Use those protocols, those standards that fits your application best. We can take the decision from you which one is the best for your application, because every application has its pros and its cons, and has the need for special functions in the protocol. But we say use the one that fits your application best, and if there are more than one, just make it hybrid, combine all of them, and make it happen.
Yeah, so this is where I'm thinking. We zoomed in into the application pyramid as Scally was explaining the whole situation of digitalization on a very abstract level, as I might say. We go back into how factories, applications, whatever really look. So here we got a lot of different protocols going on. Maybe Foundation Field Bus. Maybe we got some hard also already using connected to different remote IOs. We got still a lot of Profibus PA maybe connected with a coupler, something like that. And of course, more and more, we are talking about industrial Ethernet protocols going around. Like there are a lot of them. Know about 15 industrial Ethernet protocols, but the main ones might be Profinet, Ethernet IP, and Modbus due to the big companies that are standing behind those. Okay, now you got this whole jungle of protocols, also standards that Scally already mentioned, and how does all of this come together? Like, what's the solution for this? The solution we at Softing provide, and we are thinking about a gateway, one simple piece of hardware that is connecting all the protocols, all the standards, all the different systems together, and that is providing information, application, or the ability to run certain applications, the ability to use the information you gain out of those systems that is bearing in those systems, not used by a lot of people, the ability to make use of this information. And we identified four main use cases for our gateways, for what could be done with the information. And one is control, certainly. That means connecting new control systems, new DCSs, new PLCs to old assets that you might not want to exchange. Another use case might be process data, gaining process data. Like now, for a long time, it was the most important thing that the process was stable, like we had a lot of product output. And now we are going more into optimization and all that stuff. Also, we got asset management. Asset management, fairly important to see. Wow, okay, we got, as we saw in the last slide, we got a lot of assets. We got sensors all over the place, mile-long factories, whatnot, and keeping all those in Excel lists might be tedious. So we got measures to digitally use those systems to take care of our assets, manage them, and what we also got is health monitoring. Health monitoring, also a big thing, as most of you might heard, like the term predictive maintenance. Predictive maintenance is all over the place in context to IIoT, Industry 4.0, and whatnot. Also, health monitoring very important. So Just talking about those single use cases in a little bit more detail, not too much. So what's control about what we see here is connecting new types, new state-of-the-art control systems to already existing assets in your factory. So to say, you got a 20-year-old control system, Profibus, DP maybe, and or foundation field bus, and you wanna change that up. You say, okay, I want to use new features those control systems bring to me, but there are just the companies just are pushing, providing more and more industrial Ethernet DCS or PLCs. Yeah. Of course, they want to sell their new stuff. And what could you do now? Tear everything down, get every last bit of automation out of your system, and exchange everything with the new Siemens or Rockwell stuff they might try to sell. You could just buy their PLC. This is a little bit of invest and one of our gateways, for example, and you can connect them to your old system and via some configuration, most of the times done in the web servers of our gateways. Easy configuration steps here. You can connect your old assets, your old plant assets to the new systems, to the new controller systems. So this is fairly easy. We support a lot of controllers here, doing tests with all those here in Munich. It's easy to configure. You can keep your assets, and it reduces engineering costs, of course. What we have next, we talked about process data. Process data gets more and more important in the context of Industry 4.0, IIoT. You want to have those process data analytics. Use cases might be, okay, I have two similar plants. One is standing in this city, one is located in that city, and one produces 20% more output. I oftentimes heard that story. The solution to that, most often by now, is proposed as process data analytics. Dig deep into the data, what every step produces, what is like, how do the machines interact with each other on a physical level, whatever. You can get all of this data. You need all of this data. As Skelly explained, those are the low levels here, getting the data and transmitting it to like a analytics platform or in a cloud where it is being further processed with any system. It's very important here to have a system connected to your plant that is just offering a one way, a one direction access. Because of course, when we're talking about process data, we are directly sitting inside the automation network, and there is a lot of stuff that is critical, crucial, and can't be harmed by hackers or whatever. Cybersecurity is a big issue by now, of course, and you don't want any people to get in without permission. So the data just has to come out and be transmitted via like enclosed but standardized protocols like OPC-UA or MQTT. Yeah, make those cloud systems, analytic systems, or arbitrary systems you might wanna have the process data into. Make all those systems connectable. We use standards like OPC-UA, MQTT here. Of course, all of this stuff is controller independent. Like the next applications we're also talking about, those are all controller independent because we do not interfere with the operating system here. Asset management is done by a lot of different standards, as we mentioned. Like there's FDI, there's FDT, there's also asset management via HART. HART offers a lot of asset management capabilities, and we included all those standards into our products, so you are able to connect your asset management system, might it be field care or the different systems of different vendors. You are able to connect them to your assets via our gateway. Without it, like you couldn't support so many different systems with like just the hardware that other companies are providing here. Yeah, so You got a lot of stuff going on here. And what we lastly offer is health monitoring, as described already. Health monitoring, a big thing. Not health monitoring of the process itself, but health monitoring of the system, of the assets. Like, is everything in the automation network itself going down right? Are packets transmitted well? Are the assets still up? The remote IOs, every single card, every single module. Do we have a wire break or something like that? A lot of protocols, especially industrial Ethernet ones, or Profinet is the best one in it, offers a lot of diagnostics data that oftentimes is not being used by the plant operators, though it could save a lot of cost that is created by unplanned downtimes. For example, you would see those coming most of the times when you are doing active health monitoring. You could reduce maintenance cost, of course, and also it's controller independent here. Yeah. So in general, we offer a lot of capability, like a lot of industry 4.0 IIoT capability combined with state-of-the-art cybersecurity there. So this is a big thing, as we always talk about connecting like high layer IT systems, open out in the internet IT systems to very enclosed factory ones. Yeah. So you don't want to like plug in your factory system into the internet, of course, but you need a certain type of way to transmit the data, and you need a safe, like a diode. Most of the times, people speak about a diode in that context. You need some kind of hardware like this to access all this data, to make your systems be able to use all this data to run applications like that. And with this system, you have little to no invest. Like, the gateways aren't that expensive because you don't have to change up any kind of existing assets in your system. So because as we mentioned, the philosophy of all this stuff is keep your assets, keep your already running systems. Everything's fine with that. If you want additional functionality, we need to find a way around it to get all those applications running, to make use of all this data. And that is very important to us. So little to no change to what's already running. And of course, this has to come with ease of use. Like, it's 2019 right now. We need good interfaces, easy to understand applications, easy to understand engineering of this stuff, because we are not the main thing that people work with. So it has to be easy. We have to install it and go. It has to work. You don't have to get by the stuff day by day. You don't have to focus on those specific products we are providing. Is just install and go on, use the data we're providing, and that's it. The same as you are doing it with already running assets, for example. Yeah. There are certainly other possibilities to access the data right now in those types of systems. One would be installing some kind of an edge computer, like edge gateways, edge computers. This is mostly talking about edge computers. Have definitely advantages, as they are more open and provide you a more kind of, it's a computer after all, so it's not like a proprietary device, it's a computer. But this also bears a lot of disadvantages here, because they are fairly more complex. They need more monitoring, people who really know what they're doing, people who host those computers, a lot of maintenance, and also in terms of cybersecurity, hence they are more open systems. It gets a lot more dangerous to really implement those. You need a lot of more. You need a good IT/OT concept to implement those, and thus most of the times they are located in some layers above the PLC or something, not being able to access, not being able to really access the devices we're talking about, because we're talking about field level access, accessing field devices directly. the measurements we take. Also, the other possibility to access this data, get this crucial data out of your systems, might be through the assets themselves sometimes. So Siemens is striving for this one, obviously with their PLCs and with their remote IOs and some such, that they themselves open those interfaces like OPC UA or whatnot to access all the diagnostics data or process data and some such. But also, this comes in with the caveat that you have to exchange those systems, because if you are not using the information right now, if you're not getting all the data, you might not have assets that are able to do so. So getting all this stuff out of your system, making that step toward digitalization would mean exchanging a lot of stuff that is up and running, a lot of stuff that is costly, getting the personnel ready to work with all this new stuff and all that. So engineering cost is high, invest is high, downtimes are high in that case. So this bears a lot of risk compared to a fairly new field of applications, and you still have to, of course, figure out what's the use for you. But there's definitely big use for all those applications, and as Kelly explained.
Yeah, thank you, Thomas. With that being said, so what the key information out of this webinar is that if you want to have digitalization, if you want to get IoT, IIoT, and Industry 4.0 solutions, you don't have to upgrade or to tear down all of your plans. Most of you guys already have all this information inside of your plans, your devices, your hard devices, your 4 to 20 milliamp amps devices are ready to go. They have the information inside them. They are all smart devices, but the problem is that we don't get those data out of them and make from data information and then knowledge, and then having the best part of it, making the optimization and gaining benefit against our competitors. We have a question that has appeared asking if all these protocols down here are being supported by one gateway. So the answer is there is no gateway that supports all of these in one device, but we have um, gateways for each protocol or protocol combination. So just if you have the need of any of those, just ask us and we will help you and try to find the best solution for you. Okay.
Also, what might be important to say here, like in terms of control, we are not able to support any kind of protocol at once. Of course, as Scully explained, or like Scully explained, we got different products for that. But we are able to do all the applications we talked about at once. So we are able to connect the control system to your old assets, and in parallel with the same gateway, we are able to transmit process data. We are able to do the asset management, and we are able to get the health data and provide that to you. So this is impossible with just one product, definitely.
So yeah, for sure. We from if we say that this is the south side of the gateway, we only support once or twice at a time, or a combination of them at a time. When it's come to the north side of the gateway, we have this access in parallel, so you can do anything at the same time. You can, beside your control system, you can access your data as you want and as many time you want, and easily by connecting to the gateway, and you have access to everything you need. So yes, I think that was from our side. We have another question over here. Does the gateway convert industrial protocols to MQTT? I think I will handle this question to Thomas. Can you answer it, please?
Yeah, we don't really convert industrial protocols to MQTT. MQTT, in my understanding, is more of a wrapper protocol that you're able to wrap packets of any kind of information bitstream, protocol, whatever, into MQTT and send it out to the cloud or the overlaying system, where you want to have the data. So most of the times we are providing data by the open interface OPC UA, because it provides in context of industrial applications, or the most improved and the most straightforward approach in terms of an industrial protocol, or in terms of a standardized protocol. We map the information OPC UA, wrap it in MQTT, and send it up to the systems. Yeah. So another question, you mentioned data diode. Do we have a data diode, or do we have something similar? We have a data diode here, so you can access the gateway. The gateways offer different ports. So we have gateways with up to 3 Ethernet ports, or you'll have them, and you can access the systems by just one port in a one-way direction. And like NOAA, maybe you heard of NOAA and Namur Open Architecture. They are defining data diodes for process industry, and we are sticking to their demands and to their standards. That's what's meant with data diodes.
So the next question, how can control be achieved using this gateway, or is this fed to a PLC or a control system for control? So the answer is it's depending about the protocol you're using. So if it comes to Foundation Fieldbus has a function that it says control in the field. So we always supply a software with our gateways. So for Foundation Fieldbus, there is a communication software and configuration software that helps you and leads you to the configuration of the control system of the Foundation Fieldbus system. When it comes to other protocols, the gateways always has a web server. In that web server that you can reach through your browser, you're able to make the complete configuration of your network and connect it to your control system. So it's really depending on which kind of protocol you use. So it's either fetting up a control system that is let's say a Profinet control system, and which can also, or which will be able to control the Profibus part.
Yeah, also for most of the times for the PLCs, it would look like that there is just one device in the network that is having a lot of data, namely the whole data that is beyond the gateway. So the gateway looks like a device that has like pretty much all the plant or the devices beyond that it have to offers it itself. So this is kind of how you can imagine that. But as Skelly said, you have to do some configuration for the gateway to know what's beyond it, and for the gateway to know what to provide, and that way you can establish control fairly easily.
So yeah, the next question was, where can I get more information about this product? So for sure, we will send you after this webinar, you will also receive an email containing this webinar and all contact information, so you can directly contact us or just visit our Softing webpage. If you don't find it, try Google and it will help you to find. Just type in Softing Industrial and you will find us, our website, and it will lead you to more information. And if you don't find this information on our website, feel free to contact us, me or Thomas. My email is simply shs@softing.com. The same goes with Thomas, skt@softing.com, and we will be there to help you.
Also, if you feel like, hey, this sounds about right, what they're talking about, but the systems I'm using weren't mentioned directly, maybe, for example, Modbus RTU or whatever. also feel free to establish contact to us, LinkedIn or email, as Kelly said. We are always open for discussion, new projects, whatever. We got a lot of things that are coming out in the next half year, in the next year, and we're always up to including new functionality into our gateways that seem too important to our customers. Of course, we're open for that. So another question here, could you please share any architecture of system that uses field bus? Yeah, we could, like in that case, I think we don't have anything at hand right now to show it, but I'd say contact us via email, please, and I would make sure to really give you a detailed example of architectures that can be covered with our gateways. That would be no problem, of course.
Yeah, and for sure we have also some user stories shared on our website, and also a page that handles everything about field buses, and you can easily hit that up and try to find their information. And you will find a lot of user stories where field buses are connected to higher levels.
Thomas and Scully, we did have a additional question that came in about the physical layer and how the fact that there are multiple physical layers, and how does this gateway adapt to those?
The gateway adapts to, so we included different different adapters or different plugs in our gateway. So we have what is it called, Skelly? The field bus to wire.
Yeah, so our gateways have different kinds of connection points. We have Ethernet, we have RS-232, we have serial ports underneath it. So we really have here the connections and do the mapping and the transferring of the data from serial to Ethernet, and it will be all done by the hardware. That's why we need the hardware to really change those physics and combine those physics.
I see, thank you. And then another one that came in separately is, does your gateway need a separate power supply, or is it a power supply?
Yeah, our gateway has to be powered by like what's in the field, 24 volts, something like that, right? And it is not a power supply, so it does not act as a power supply to the field bus it is connected. So in terms of industrial Ethernet or Profibus DP, every device has to be powered itself. Also, this is no problem due to no X capabilities in those protocols. But if you talk about field bus, Profibus PA, Foundation field bus, and so on, our gateways do not provide power to those systems. You have to, but you can use existing power supplies on the other hand. So you don't have to interchange that up. We do not interfere with power supplies of different vendors here.
I see. Thank you.
Yes. Here I see another important question. Yeah, we are if we are planning to integrate PADIM and OPCUA information model. Yes, we definitely are. We are planning to integrate PADIM. We already, or we are going to release a product in about half a year or something that is including the OPCUA companion specification regarding Profinet diagnostics information and asset information. We are working on a product that is going to be released containing this model inside. Yeah, of course, we are bound to include all of those standards into our systems. That just makes sense.
Mm-hmm.
Well, yeah, if I can add something to that, we're definitely working on those gateways, so they are all state of the art. And if new technologies appear, new specification comes out, we are directly also working on those specifications. So we are also working on them and try to integrate them into our system as soon as possible and as fast as possible.
So there's somebody asked if there's a fiber connection interface. No, there is not. Unfortunately, we do not provide this so far. Yeah.
for me will be interested. So because I my personal work life didn't see a lot of fiber optics used in process industry. So if you could let us know about your application, this would be great. And um, as Thomas mentioned, so we are open for new things. So if you have a need for it, just contact us. We will try to help you out with that.
And we definitely we got fiber technology in-house. So as we mentioned at the beginning, we are consisting of 3 business units, one being IT networks that is doing a lot of cable testing, qualification, certification. And they also, because if we go in higher speeds and something, fiber becomes more relevant, also covering bigger distances. And they provide physical testing for fiber, most definitely. So qualification and certification. So knowledge is definitely here, but we did not plan on any products directly, but we're open for discussion.
Okay, well, it looks like that's all the questions that we have coming in today. I want to thank Thomas and Skelly for an excellent presentation. And on behalf of automation.com and Softing Industrial, I would like to thank each of our attendees for your participation in today's event. As a reminder, if you missed any portion of this webinar or would like to re-watch the recorded version, we'll be emailing all registrants a link to the recording. Also, a post-event survey will appear that will request some feedback, so do feel free to let us know if this topic met your needs, if it came across as identified, and if you have any additional questions, we will be sure to pass them on to the presenters. This concludes today's program. Thank you all very much and have a great day.
Thank you, everybody. Auf Wiedersehen from Germany.
Auf Wiedersehen, guys. Auf Wiedersehen.